Posso andare?
Ok.
Posso andare?
Yes.
Ok.
Yeah.
Okay. Good afternoon. Can I start? Okay. Good afternoon, everybody. Okay. I hope that you spend a great weekend. Okay. If you remember last time, we talked about model-based testing. That is a sort of automation of testing. And thanks to model-based, we can automate some steps of the testing process, such as the generation of test cases and the execution of test cases. Thanks to model-based testing, we can help the tester, avoiding them to write test cases that, as we saw in the first block of slides and the first day, they are actually code that should be developed by the tester. And we can avoid this activity, and model-based testing is one possible approach, or it's one possible methodology. As we observed in the last lesson, for performing or for executing a model-based testing approach, we need a model. We need a model that at the same time represent the structure of the GUI and the behavior of the GUI. And as we recall, the behavior of a GUI is represented by the events that the final user can trigger on the user interface. Okay. Now, what is the problem, or what is one issue of the model-based approach? We need a model. Okay, that could be a finite machine. If you remember, a finite machine is a graph where each state represents a abstraction of the GUI. The arrows in the finite machine represent the events that are triggered on the source state, and that may generate a new state. Okay, when you click or when you execute an event on a GUI, usually the GUI changes. When I have the classical example of the login page, I interact with the application, I insert the username and the password, then I click on login or click on submit, and what I see that the user interface changes. Okay. Now we need the model. We need the model of the application to apply model-based testing, right? And how do we build the models? Probably the models are built manually. There are experts in modeling that knows UML, and starting from the requirements, model the specification or specify the requirements. And the requirements can be specified by using UML model or specific or extension of UML. Usually, the model that are used for representing the GUI of the application are finite state machine, event flow graph, and as Professor Termination said, asked, in some cases we may have other kinds of model, like sequence diagram, like activity diagrams, but usually finite state machine are the most used for representing the GUI. Now, we have the problem to build the models, okay? Is it possible to test the application without having a prior knowledge of the application under test? Yes, it's possible. And this is one of my main research activities regarding that are named as online testing techniques. Okay. Usually, the testing techniques may differ on the basis of on how a tester implements or executes the two main steps. You remember the two main steps? The two main steps of a process are test case generation or test case definition and test case execution. Okay? And the two steps are distinct in time, are separated in time, in the sense that the test execution can be done either offline or online. Offline means that I design test cases, then after 3, 4, 5 days, when I finish the design of the test cases, or the generation of the test cases, I can implement them and I can execute them. In online test cases, there is no difference in time. Test cases are generated and executed at the same time. So, at the same time, in a given time, I have the generation and the execution of a test case. The online testing techniques are the most automated testing techniques because you can select the application and you can test the application on the fly. And today, we will understand how it is possible. And why these testing techniques are fully automated? Because they do not need a knowledge of the application, and they are able to generate the test cases automatically and to execute them. Okay, how the online testing techniques are implemented? Online testing techniques are implemented by robots, or nowadays we use the term agent. So the agent or a robot is the robot is the agent that is devoted to execute an online testing technique. That at the same time, the robot explores and tests the app. It combines reverse engineering techniques and testing techniques. Now, let's try to do some examples. Okay. No. So I use the blackboard. Okay. Do you know the term exploratory testing? Exploratory testing is a kind of testing where you do not have a knowledge of the application and you use the application, explore the application in order to find errors, failures in the application, right? And you explore the application. Okay, so what is that? The online testing techniques can be considered like testing techniques performing exploratory testing. Okay? Automatically or manually? Fully automatically. It's fully automated. Okay, I can explore the application under test also manually. Did you ever try an exploratory testing? I believe yes. Probably one time a week you go on App Store or on Google Play Store, you download the application and you try the application. If the application does not present a crash, if the application is usable, if the application does what you expect, you accept the application and you do not uninstall the application, right? You tested the application. You explored the application. Okay, now I want to tell you a story that I had yesterday. Okay, what is the name of the park?
Ecological park.
Okay. Yesterday I went to the ecological park. Do you know the ecological park? Okay, great. When I arrived in ecological park, I was in a big place, right? And at the beginning, I had in front of me 3 ways to follow. I did not analyze any map, okay? Sorry for my... It's like an octopus, but it's not an octopus. This is the stuff. Okay. I arrived here with Uber. Okay. And I worked and I tried these 3 ways. Okay. Imagine that we are in the same situation. At this time, as an example, Misa, when you go in the right, in the middle, or in the left?
The left.
Okay. In the left. Misa goes here. What's your name?
Luana.
Luana. Okay, Luana, where you go?
To the center.
Sorry?
To the center.
The center? Okay, great. Misa?
I can go to the right.
Okay, to the right. Okay. You?
Center.
Center. Okay, we are 2 in the center. 1 in the right, 1 in the left. Right? Okay. Okay, I have to choose. That? Okay. I don't remember where we go, where we went. Okay, but imagine that I follow the center. And I arrived here, in another place. Okay, I see many animals, very nice tree. Okay, I took some pictures. Okay, great, right? Now, here, I had other choice to follow. Where I go? On the right or on the left? Misa? Right. Left. Okay. You, Luana?
To the right.
On the right. Okay. Misa? Stefano?
Go to the right.
Okay.
Yeah.
2 on the right. Okay. He's following you, eh? And you?
Left.
Okay. On the left. Okay. So, we are building a map. Okay. Imagine that here I follow another way and I return here, right? I stay again in this place. Okay. Now, Misa, you go left, center, or right?
I will continue left.
Okay, in the left. And you go on the left without know. Okay, what is in the left, right? Okay. Luana?
To the right.
Okay, you go right. Okay, can I use different color? Okay, Misa goes on the left. Luana goes on the right. You?
Now I'm
The right.
in the now I'm going to the center.
Okay, in the middle.
Because
Because
I want to explore.
yeah, great. Because you, or I don't remember. You was
Yes.
yeah, you was here. Okay. You okay? Stevao used another algorithm because Stevao remember that okay, in that place I explored on the left or right, and I remember that there is another way that I did not explore. Right? This is your rationale, right?
Yeah.
And you?
Right.
Okay.
Right.
Okay. Again on the right. Okay. Miso, Luana, Stevao, and you use a different algorithm. Okay. And let's think what we did. We are building a map of the botanic center. It's botanic center? No.
Botanical
Park.
Okay, I don't remember the names. Okay, it's my that's my property. Okay, Amalfitano remember the name. No. Okay, so we are building a map of the park, right? So when I perform an exploratory testing, I am in an explored space. It's like a robot that, do you know Roomba?
Yeah.
Roomba,
Cleaning robot.
yeah, the cleaning robot. When you put Roomba in an angle of your floor, Roomba explores the space and builds a map. Okay? And the robots or the agents implementing online testing techniques explore a space that for them was never explored before. This is what I did for research. No, yes, I did for research for some minutes during my PhD. Okay? And they are fully automated. Now, let's start with some configuration. Okay. First, configuration. If we see the online testing technique are black box, okay? Because we are in the GUI based testing. So for me, the application is a black box. I interact with the GUI, with the user interface of the application, okay? So for me, it's a black box. This is the discussion that we had the first day. GUI testing or GUI-based testing. For me, in this case, it's a GUI-based testing because I'm trying to explore the application through the GUI. I try to understand how the application works through the GUI. I want to find failures through the GUI. Okay, now when when I go to the park, when I went to the park, my target was to work, okay? In online GUI-based testing technique, the target are GUI events. The target is GUI event. The online testing technique has to produce GUI events. The main goal of online testing techniques, the main goal, not for me, but usually for the publications that you find on Scopus or the publications that are published, that are online, the main goal is to find crashes. In alternative, code coverage is another metric for evaluating the effectiveness of online testing techniques. So imagine that you interact with the GUI and in parallel you measure the code covered by the events fired on the GUI. Okay? Usually you can run them on emulator or real devices, and these are the test environment. In general, if you consider these online testing techniques in the web are also known as crawler. Do you understand? Do you know the name? Crawler. The crawler is a robot that automatically explores a website. You give the website to the crawler, and the crawler explores the application for you, save the pages. Google has its own crawler that is used for indexing the pages. Okay? From my point of view, usually I try to build agents working both on emulator and real devices in order to assure both the test environments. Okay? Yes.
What's the major difference between the running a crawler in the emulator or in a real device?
The logic is the same. The difference or the difficult is only I don't know if they agrees with me. In my research activity, in some cases I have scientist problems. This is a scientist problem to define the algorithms and so on. On the other side, I have engineering problems in order to have a theory and to execute that theory. The problem, the difference between emulator and real device is an engineering problem. I have to find a way for apply the same algorithm in two different platforms. One that is the emulator and one is the real device. As we will see in the next of this class, when I implement in online testing techniques, I have to recognize the GUI, I have to interact with the GUI, I have to have a description of the map of the GUI. From a theoretical point of view, I have no difference between an emulator and a real device. It's the same, the algorithm. The problem is to find the framework that allows me to execute the online testing technique on the emulator and a framework that allows to me to execute the Reaper or the crawler in the real device.
Okay. I was thinking on Android emulator.
Yeah.
For Android, it's basically the same thing.
For Android, I had no problem to run the emulator or real device because I can use the ADB for sending the same sequences of events that I run on the emulator on the real device. I had no problem. Maybe I show you a problem that I had the last day when I present Jugular, that is the other tool that combines machine learning, exploratory testing, and capture replay. Yes, in a single technique, we have all the possible techniques, no, almost all the possible techniques, and in that case, I had to solve this problem. But from the point of view of mobile devices, I did not have problems. The tool that I developed works well both in both environments. If we consider an embedded software systems, oh yeah, in that case you have a lot of problems.
There's a question of Marcelo.
Okay, tell me, Marcel.
Marcelo asked, Google crawlers handle all four
Can I see?
errors unless a valid handles a robot.txt file. This means that Google assumes there's no crawl. Right?
Okay, I don't know how to ask to this question because actually I don't know in details how the Google crawler works. So I know that you can configure the robot.txt file in order to help Google to reach the pages of your web application. So I don't know if these are the only information that I have on how Google crawler works. And I don't know if I answered to the answer of Marcelo. If Marcelo gives me a feedback, it will be great.
Okay.
Marcelo. Okay. What was it, Marcelo?
Yes, yeah. He understand.
Okay, thank you, Marcelo. Sorry. Okay. Some theory, because we are in university. According to Rottenberg, this is the paper. In some slides, you find the main paper that can be considered as related of that slide. It means that that paper can be for you as a pointer for performing a snowballing process. Okay, so you start from that paper, read the paper, go in reference, go in Scopus, and you can see the backward and the forward references on the paper. Okay. According to Rottenberg, these techniques can be defined as dynamic event extraction-based GUI test case generation techniques. And now, after this slide, we understand why they are called as dynamic event extraction-based GUI test case generation. So, this point, I believe that I told about this point billions of times during my presentation. Test cases are sequences of events. So if Wednesday you will find the question on what are test cases, test cases are sequences of one or more GUI events. And the test cases are executed on the fly as soon as they are defined at runtime. Okay? Okay, let's see how in exam or in GUI testing, online GUI testing techniques works. Okay, do you know this application? This application is word reference. No? Sorry, not the word, WordPress. You know WordPress? Sorry. I was thinking to another application. It is WordPress. Okay? This is a real exploration that I performed and I presented in a couple of papers. Okay. You install WordPress for the first time. You have 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 10, right? 10 buttons, right? Okay, Stefano, which button you choose?
I can't read from here, but probably I would click on new or something like that.
Okay, you want
The thing.
the first one?
Yeah.
This one? And you?
The first button, new.
The first button is?
Yeah.
Okay, my crawler rotate. The crawler rotate the application. So, in the rotation is another event, right? You can rotate your device. Yeah, rotate. Then from vertical orientation, you can go on horizontal orientation. Now, what means here? The robot considers the two GUIs as equivalent. It's like, okay, I go back to the beginning and the robot says, okay, this GUI, I already encountered or already explored this GUI in the past. So probably it's an algorithm, you can change the algorithm. Probably I do not want to explore more this application, this GUI. It's strange for you? You have the same widgets. It depends. It's my choice.
But
Yeah.
why the robot considers the same interface?
Yeah.
Because it did not recognize an event, or because they can compare the two interfaces.
Okay. In as we see in the future, and when I will go in details of the algorithm, the robot has some criteria for comparing the GUI. In this case, that is one possible criteria for comparing the GUI is to consider only the structure of the user interface. If you remember, on Friday, I said that a state is an abstraction of the user interface. So the robot, step after step, does not consider all the GUI, but it has an abstraction on the GUI. It may consider only some widgets, but it can consider also all the widgets. What is the problem if I consider all the widgets and all the properties? The problem is that I have to store space. I have to store this information, so I need space. And when I have to compare one and more interfaces, probably I need more time for execute. So it's a trade-off between the time of execution and the abstraction of the state. I don't know if it's clear.
Mhm.
In that case, it's an example. I consider only the widgets that are active, in the sense that only the widget on which the user can trigger an event. But it's a choice, Adela. You can configure. As we will see in the second hour, the algorithm has some parameters, and on the basis of the parameters, you can change the expression. Okay?
Thank you.
Okay, then I click on new post, and I have this information. Then it clicks on refresh. And if you see, refresh and the starter page are equivalent. Then I press on menu. And I click, and I click on pages. Okay? If you observe this kind of navigation, guys, you can observe that the navigation is in breadth. But it could be possible also by going depth. As we will see tomorrow, we can go by random. As you will find in the literature, you can combine. You can go in depth, in breadth, random and breadth. You can change your strategy of exploration. Okay, then I go on, click on save, click on add, click on about, and if I click on edit, I find a crash. This is a real crash that was, I don't remember the version, it was a a paper of 2017, I don't remember. But in that paper that was published in Automatic Software Engineering Conference, we found real crashes on WordPress. The robot automatically, in 3 hours of execution, found failures that were never never were found before by the users and by the developers. Full automated. And okay, this type of map is also called GUI tree. In literature, it is a GUI tree. Tree, that is albero in Italian. It's in Portuguese. The tree is
Arbori.
Arbori. Okay. Indeed, you can see the map of the application. It's like a map of the website, right? Starting from the root page is the page, or sorry, the root GUI is the root that you have once you open the application. Yeah.
Well, but it's not really a tree because you can go from one place to. I mean, one node can have more than one file, so it's not a tree.
Yeah, in this case, you have if you define the equivalence between states, and you put the same state, if you merge equivalent states, in that case, yeah, I agree with you. But if you consider all the states as different, you have a tree.
Okay, so you can have I mean, same state can appear more than once.
Yeah. After, when you collapse equivalent states, you have not a GUI tree, but you have an infinite state machine.
Okay.
Automatically, you can build the model of the application. So after a testing session, you have the results of the test that are automatically obtained by exploring the application, and at the same time, you have a finite state machine of the application, of the application under test. And you can have a finite state machine or an event flow graph. So at this point, let's think about one possibility. We can change our testing process, okay? Because we can start by launching the robot or the agent, perform a first session of testing. At the end, we obtain the model, and on that model, we can apply a model-based testing approach. So it's fully automated. I launch the exploration, I build the model, and I launch, and execute a model-based testing approach. Okay. Now we have different parameters that may influence the performance in terms of testing capabilities of the online testing techniques. As an example, when we can stop the process, let's return to the ecological part. Okay, Luana, when you finish to explore the ecological part? Okay, when you see everything, right? Okay, Stefano?
When I got tired.
Okay, great. When you go tired, it's okay. It's okay because it's the first stop criterion in the industry is the time. I have 5 hours to testing because, or I have 1 day for testing because tomorrow I have to deliver in my application. I have 1 hour or one day. In some cases, I cannot perform the stop criteria or one to visit everything. I should be pragmatic. I have 1 day, okay, I exploit 1 day. When my machines are target. Okay, it's like you. And you, when you stop.
When I reach the beginning again.
Okay, so if
Okay.
you perform this part
Yeah.
1 time and you go to it. Okay, so you did not explore anything. Okay, it's another algorithm. But
When it starts to rain,
when it starts to rain, okay, it means that when you have no resources, okay, it's Friday, everything is closed. Okay, it's not rain. Yeah, but as an engineer, or as a practitioner, or as a researcher, we should be aware of the fact that our choices may influence the results of the testing process. Probably Luana will reach the best coverage, but the process followed by Luana needs a lot of resources in terms of time, in terms of machines, okay? Probably his stopping criteria is the faster one, but probably he will not cover too much, but it is a criteria. Okay? Okay, how the next sequence of events to be fired is selected? When at the beginning I asked you, Luana, what is your first election? Stefano, what is your first election? What is your first election? And you said me different event of sequence of events, okay? Because this is the sequence of Luana. Luana goes there, return at the beginning, and then Luana decided to go on the right, okay? Stefano has another strategy. He decided to go in the middle, then when we returned at the beginning or at the starting point, he decided to work again on the same point, right? It may influence the coverage, it may influence the results of the testing process, right, guys? Okay. Okay, I want only to do a little jump. Probably I forgot to give you this definition. The dynamic testing techniques, guys, or the online testing techniques are also known as active learning techniques. Active learning means that the process builds a model of the application under test. I have to repeat. When you build a dynamic testing process, an online testing process that builds the model of the application, is called as active learning. In this case, it is active learning because the agent, the robot, builds the model of the application. Okay? Okay? If I build the model of the application, I'm implementing an active learning technique. Okay? It's clear? The definition? Okay. This is the problem that Prof. Delamaro pointed out. In case of active learning techniques, in the case of techniques where you build a model, when two user interfaces can be considered as equivalent, this is a problem. Why? Because everything can change. If from my point of view, two GUIs are equivalent. And I decided to not explore the GUIs that are equivalent to other ones. The problem of the equivalence is a problem that influences a lot the results of the exploration. Because I can find or not GUIs that are equivalent. I don't know if it's clear, guys, this point, or I can repeat. Okay, let's do an example. Or maybe we should stop for
10 minutes.
Okay. Okay. Do you see? I don't know if I told that I see the figure. If it's not clear, I can improve. Do you see this GUI? Do you see one? Okay. Where do you click one? A one or a two?
The first button.
A1.
Yeah.
Okay. Okay. Now I have another GUI that has a lot of text, and the one and the two, the same buttons. For you, Luana, these two GUIs are equivalent or not?
No,
No? Why?
because it's different pages.
Okay, different pages. Why they are different? Because there is a text.
I think they're different, but maybe they can be equal if they just got like to the bottom. of the page.
Okay, okay, but for you they are different, right?
Yes.
Okay. For Luana, is it correct? Okay. Different. Stefano, different or they are the same? I'm saying that the two buttons are the same. They perform the same execution. They are the same or not?
They are not the same.
Not the same. First name is
GU.
J.
J.
For you, different or the same?
They are different.
Okay, they are different. Then I can ask it to you.
Well, I must say they are the same,
Okay.
but the actives, the widgets are the same.
Okay. You are, all of you are right, and all of you are not right. Are wrong. Yeah. It means from the level of abstraction. So, Luana, Stefano, and no, after write your name. Okay.
No problem.
Consider the GUIs as different because probably in your abstraction you see another configuration of the GUI. You see new text and the new layout of the buttons, right? More or less, this is your rationale, Luana? Or
Yeah. But
Yeah.
maybe their actions are different.
no, I said the actions are the same.
Actions.
Yeah, if you go on one, you have the same interface. Probably I missed to say this. The same. It's the same behavior and the same structure. It only changes because I see text and different position of the widgets. Then had the same, my same idea, my same, I don't know if we can say intuition at the beginning of the PhD. I considered as first abstraction of the GUI only the widgets where you can file events. If the handle, I come to you. If two widgets are the same in the sense that they have the same handles, I considered, but it wasn't my choice. I'm aware of the possibility that my choice can be lead to results that are not sufficient as yours. Okay? What is the problem now? No, what is the implication? If I consider these two GUIs as not equivalent, probably we are in the same situation where we find a new place into the ecological park. So I can continue to explore it. If they are not the same, if they are the same, like this is the idea, my idea and the Della idea, probably I did not continue to explore this good because it's equivalent to the other one. Okay? Yeah, I may have a counterpart in this abstraction. Probably, if I continue to explore the same GUI, because it changes in the layout, I can find new things. Probably this is your intuition. What is the problem if I consider too much? I may have an explosion of the states. Do you understand an explosion? If I consider each new GUI as different with respect to the other ones, also by a little difference, like the test or the layout, I may have an explosion. And I need too much time to finish my exploration. I have to choose a trade-off between exploration and time. Question.
My point is, how can you guarantee that the text have no events related to
Okay. This is a good question, but it is an engineering problem in the sense that it depends, because from my point of view, it is a reverse engineering problem. If you remember the slide at the beginning, the robot also do a reverse engineering process. In my robot, I am able to describe the GUI, and for each widget, I can understand if the widget has an event handler or not. If the widget has not an event handler, I decided to discard the widget from the abstraction of the state. You can say, okay, but how you can guarantee that the handler is the same? I can consider the code, I can match the code of the handler. You can say, okay, but how you can guarantee that the input values that you put on the GUI change or how the textual values may influence the navigation. I don't know if it's clear this example. I do this example and then I do a stop. It's only let's try to do the things more difficult. I have a text value. text box, okay? Name. Button A1 and button A2. Imagine that if I write here hi and I click on A1, and A2. If I write here, how do you say hi in Portuguese?
Oi.
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 Can you spell me?
O.
O.
I.
If I write oi, and click on the one, I go to another user interface that is oi and the one. So what happened here? I had the same click. I performed the same event, but the text value influenced the navigation. It means that somewhere in the code there is an if statement or a switch case that on the basis of the text value you reach different user interfaces. And in some cases, if I leave the text of values empty and I click on one, is the programmer did not consider the null, you may have another exception due to a null pointer. So you can see that all these choices, all these all these choices may influence the navigation and may influence the results of the testing process. So only another history, when I implemented this tool, that is Android Reaper, I had a lot of citation. It was a good paper. And I observed that, okay, at a given time of my research, after 3 years, many dynamic testing techniques on Android were presented. And at that time, with Professor Fasolino, we decided to define a unified algorithm that is able to describe all the dynamic testing techniques that were presented in literature. And we presented a framework that can be used for comparing fairly different testing techniques. The publication was a JSS paper, that it is one, a general framework for comparing automatic testing technique of Android mobile application. So we defined the conceptual framework starting by analyzing all the dynamic testing techniques presented in literature. And thanks to this framework, we were able to compare not the tools, because the tools depends on the way they decide to stop, the way they decide to file the next event. But we, from a conceptual point of view, we were able to compare the tools by considering, in general, the criteria used for explore the application. And we performed an empirical study by using this framework. The results of the study will be presented tomorrow, because one of the exploration strategy is the random one. And tomorrow I will talk about random testing. But in the next, believe 40 minutes, because now we have 15 minutes of stop, I will present the unified online testing algorithm. Okay, the algorithm is on the slide, but I will try to explain step by step. Okay? Question? Yes, Marcelo.
I made a question.
What are the best eye-tracking tools and what they? Okay, eye tracking. For eye tracking, you intend the ones that follow the eyes. Oh, there are many, but I did not use them for my research, so it's a little out of my research activity. I don't know. I know that there are eye tracking that are used for usability testing, but I never used them. Sorry.
Okay. That is our questions. We can pause for 50 minutes.
Okay. Okay, welcome back, guys. We have 40 minutes, and I want to present the online testing algorithm that we presented in this paper. And probably in this presentation, I try to tell something that could be useful for Anna, that asked me a question in the chat. For some applications in industry. Okay, the framework this framework tries to summarize the main behavior, the main algorithm that is at the basis of the exploration strategies that have been presented in literature. How we inferred this model? We collected the papers, we collected the tools presented in these papers, and we analyzed both the papers and both the source code in order to understand, in order to understand how the tools work. I'm talking about tools implementing online testing techniques, and we analyzed the code, we read the paper, we tried the tools, and at the end we built this framework. Okay, what we observed? We observed that all the techniques expose a common iterative behavior. So the techniques are iterative. Where a sequence of events are scheduled and executed through the GUI. If we return to the event, to the example of the biological park, at each step, each time we reach a place that is new or already visited, we decide to follow a way or another one. Okay? And if we map this with the exploration of GUI, each time we find a new GUI, we have to decide if this GUI is new or not, and if the GUI is new or not new, we have to decide which events to plan and to execute, right? As an example, I can decide to avoid the execution of events that we already triggered in the past. If I return in this GUI and I know that I already performed the trigger or the click on A1, the next time I find the same GUI, I can decide to perform the click to A2. Or it is possible that from my point of view, I want to decide to click again on A1. Probably by changing the values on the text label, on the text box, sorry. And when the iteration process stops, when I reach a termination point, that can be the time, or if you are tired or not, if you explore everything, that is the case of one, or if I return for the first time at the beginning of the application, like the choice of junior, right? Okay, so these are the set of parameters that usually the testers have to set, and that we infer from the literature. The termination criterion we will see in details But by the names, you can understand what I'm saying. Termination criterion is the criteria that is chosen by the tester to decide when stop the execution of the exploration. The exploration strategy, learning strategy, extraction criterion, and scheduling strategy, I will present them slide by slide. Okay? Now, if you see, the algorithm is iterative. So while the stop condition is not met, I explore the application. Okay? While I'm not tired, I explore the application. While I did not visit everything, I explore the application. While I did not reach the beginning of the application the first time, I continue to explore the application. It depends, it's a choice. But the behavior is the same. All the studies, all the online testing techniques, almost all the online testing techniques proposed in literature follow this algorithm. What changes, or what the researchers, or our colleagues changes, are the parameters of the algorithm. So, at the end of each iteration, the stop condition is evaluated. I'm tired? Yes, no. If I'm not tired, I continue. I considered everything. I visited all the ecological park. Yes, okay, I can go home. It rains, okay, I go home. Okay? This is the stop criterion. I have to decide. But the algorithm is the same. To answer to Anna, that is following us in chat, on webcam, as an example, in industry, the time is used in order to visit the application in a short time. Usually the navigation, I have some experience with some industry, but I cannot tell you the name of this industry for non-disclosure agreement, but I know that many industry, each time a new version is deployed, automatically the Reaper or the crawler is executed to explore the new version application. Okay, this is not the silver bullet. Do you know the silver bullet? The solution for each problem. In some cases, there are also, as I said to Anna, smart exploration. In this case, the exploration starts from the scratch. The robot has no knowledge of the application. But in some cases, you can configure the online testing technique, and this could be a solution for Anna, for exploring only a part of the application. I don't know if I try to understand. Imagine that you had a new button on your application, okay? So you had a new feature on your application through a button. Okay, imagine that this is the application. This is for Anna. This is version 0 of the application, okay? And I already exploded the application, right? Imagine that now I have a version 1. In version 1, I add only a new button, okay? And the behavior of a 1 and a 2 does not change. from a pragmatic point of view, from a practical point of view, if I have not so much time, I can configure the Reaper, or I can configure the online testing strategy to explore only A3. Actually, if something changes on the behavior of A1 and A2, I have to explore again A1 and A2. Okay, I don't know if I answered to Anna, and if she gives me a feedback, it could be a possible solution for her. Okay, it could be a practical solution in industry. I did not report these in the slides, but the configuration of an online testing technique to perform a predefined sequence of events before starting the exploration is called as pre-crawling. As an example, imagine that this is D1. I click on A2, and after A2, I have two buttons, B1 and B2, okay? Imagine that in version 2, the behavior changes, and when I click on A2, I have another behavior, okay? Now, if you want to force the online testing strategy to explore only A2, you can configure the exploration strategy to say, okay, launch the application, click on A2, and then explore the application. In this case, the initial state is not this one, but the initial state is open the application, click on A2, and then explore. It's something like, okay, I go in the ecological park. I explored a part of the ecological park, then it started to rain, and I come back to home. I return to the ecological park the day after. Why I have to explore the part of the ecological park that I already explored? I can explore the part of the subset of states of the ecological park that I did not explore yesterday. So I can have a precise starting point of my exploration. So I go to the state that I encountered for the last time yesterday, and I start to explore the ecological part from that state. And this is called pre-crawling. Okay? Now, the abstraction, if you see, if the exploration strategy is active learning, what means active learning? That I built a model of the application. Okay? So, if I build the model of application, then I have to update my model step by step. There are techniques such as the random, where you do not build the model of application. But if you want to build the model of application, step by step, you build the model. Like in the ecological park, I visit a new place with new animals, with new trees, and I build in my mind the model of the ecological park. Since I forget everything, I did not build the model. She helps me in in implementing the model. She remember where we stayed before, and we have to work and we can visit new places. I go by random until I'm not tired. Okay? So here the extraction criterion. The extraction criterion is the criterion that is defined, that is used for extracting the events that you want to fire on the GUI. Is the criterion that define which are the GUI, the events that can be extracted from the GUI. Let's do an example. Okay, I have in a user interface, I have menu 1 and menu 2. I have 3 checkboxes. I have 2 buttons. When I encounter this GUI, what I have to do? I have to extract from that GUI the events that I want to fire. Okay, as an example, 1. Which are the events that you would like to fire on this GUI?
You can click the 4 buttons and discover the events.
Okay, so you want to click on the 2 buttons only?
The checkbox.
And check the menu?
Yeah.
Okay.
It's a menu.
Yeah, we have 2 menus. So you want to extract everything, right? And click. And click only?
Yeah.
Okay, for now, yes. Still?
It's a good start.
Yeah.
Maybe I can verify whether the checkbox have different behavior if they are selected or not.
Okay. Okay, so you want to combine
Yeah.
these events with other events.
Yeah.
Junior, what do you do? Because we are building a robot, but when you build a robot, the robot is like a child, and you have to teach the robot how to perform. So we are teaching a robot, we are teaching a child to walk and to explore the space. But at the same time, I want to check if there is some crash. Okay, Junior?
Maybe testing one.
No, I am extracting. So I have to build here a list of the events that I want to fire on that GUI. Stefano say, I want to click on B1 and click on B2, click on M1, click on M2, select, check 1, check 2, and check 3. This is the extraction criteria. You have to have a strategy that for each GUI says you which are the events that you want to fire on that GUI. Yes, tell me, Luana.
And you can combine all the possibilities.
The combination is the scheduling strategy or the execution strategy.
But if you combine, it's another state, right?
It depends if I go to another state or not.
For instance, if you select
a checkbox,
one, then you have an event that will change the GUI.
Yeah, maybe.
So you have another
Yeah,
state.
maybe I can have another GUI. If in the abstraction of GUI, two GUIs having the checkbox selected are the same or not, it's the same. It's a problem, not a problem, it's a choice. All the combination of this parameter.
Is this also a parameter?
Yeah. All these combination of parameters may influence your navigation and may influence the results of the navigation and may influence the results of the testing activity. Once we have extracted and planned which are the events, what I mean for planned, imagine that we click on B1, okay? Then we return at a given time of the navigation on the same GUI. Probably I remember that I already triggered B1. I can decide to avoid the triggering of B1 the second time. Do you agree? It's another option. In some cases, I want to stress the application by clicking always the same button. It can be done in some vulnerability or stressing testing activity, because don't forget our main goal is to test the application. In some cases, if I want to run some penetration testing approach, probably I want to test the behavior of a single event. It depends. The scheduling, the execution, the extraction of events depends on the configuration of this parameter, depends on the goal of our testing technique. Okay? Then I have to run the event. Okay? Now, in the slides, I reported the parameters that we found in literature for each the values that we found in literature for each parameter. But for research activity, you can build your own online testing technique. If you are performing testing activities for extended realities of the system, maybe you have to define new parameters, because in that case we have no more the concept of GUI, but we have the concept of scene, a 3D scene. So we have no more two-dimensional object, but we have three-dimensional objects. We have other events. I can rotate my world. I can see the world by upper, by the left, by the right. I can change my point of view. I can have other events like the picture. I don't remember the name of the event. But we are changing the infrastructure, and probably if I change the domain, also the exploration could change. If I have a virtual world representing USP, and I want to check if the navigation is correct, I have to change the navigation of a 3D space. And it's challenging. It's nice, but it's challenging. It's virtual reality exploration. Yeah, it's nice. I don't know how to do, but it's very nice. Okay, now I go fast. If I don't finish, you have the slides, but all the values you will find in this paper. Okay. As an example, as for the exploration strategy, the exploration strategy parameters defines if you want to build a model or not. These are the parameters that we found in literature. In literature, we found active learning approaches or random approaches. There is a new, I don't know if you know Pekkau and Tanja Vos. Pekkau and Tanja Vos are two researchers in Netherlands. They are combining random and active learning. At the time of the paper, there were only approaches that were either active learning or random. Okay. Now there are parameters that are exploration strategies that combines both. Okay. So random means that I don't want to remember, like me. Okay, I work and I don't take care of what I encountered during my exploration. There are other approaches. Okay, I'm active learning. I build a model. I want to know where I am. Okay. Okay. Active learning combined together with testing and model learning techniques. Model learning. In some cases, it's a very new topic where active learning and model learning is strictly related to AI, where I apply AI for understanding better the model that I'm building at runtime. So there is, as I will show you very briefly in the last day, yeah. Now the hot topic is to combine AI in software engineering. So AI is applied to requirements, to software development, and from my point of view, to software testing. And there is a new research topic where the AI is applied to the exploration strategy. So if you are working on AI and you want to apply your AI data mining, so what you're doing, and you want to apply this topic to software testing, it's an hot topic. Okay. Learning strategy. The learning strategy is the parameter that tells you which kind of model you want to build at runtime. If you want to build a runtime a GUI tree, if you want to build a runtime a fixed machine, if you want to build a runtime an event flow graph, or if you want to build a runtime another kind of model that you want to propose to the research community. There are GUI tree, event-driven LTS, but usually they are all possible model belonging to the family of finite machine. Okay. Okay. How I can abstract the type of the GUI? There are three approaches proposed in literature for mobile, as an example. Two GUIs are equivalent if they have the same activity name. Do you know what is an activity? The activity is the name of the object implementing the GUI. Other, we defined sub, single attribute value. In this case, the GUI state model is associated only to the GUIs, only to the widgets of the GUI, assuming the same value for just a single attribute. MAV, multiple attribute values, in this case, is the state of the model is associated with all the GUIs having the same set of widgets and the same values of a subset of widgets attributes. Both sub and mav are configurable. Let's do an example. For sub, these two GUIs are equivalent. Because, as an example, if I consider as attribute the type of the widgets, we have 1, 2, 3, 4 widgets of the same type. As an example, this is a label, and I have a label here. I have an image here, and I have an image here. I have a label here, and I have a label here. I have a button here, and I have a button here. So, from the point of view of this very simple abstraction strategy, the two GUIs are equivalent. If I consider multiple attributes, the two GUI are different. As an example, the labels has different text. The images are different, right? So these GUI are different. The termination criteria. These are the termination criteria that we've usually found in IntelliJ. You stop after the execution of predefined number of events. Probably this is the termination criteria of junior. Okay, I want to work only 3 minutes. I want to work around, and when I find the first time the beginning, okay, I go to lunch. Okay. Okay, this is the termination criteria of Stellar. The loop ends after a predefined time of execution. After 3 hours, probably I'm tired and I go. These are the termination criteria that is chosen by Luana. I stop the process when I do not find new states. It means that from my point of view, from my point of abstraction, I have explored all the GUI of the application on the basis of my abstraction criteria. This stop criteria, it's specific for random, and it will be presented tomorrow. Yes, let me tell that.
What happens if I find a fault?
Okay, when you find a fault, usually you store the sequence of events because they are very interesting, and you start from the beginning.
So it's a termination.
Yeah. No, termination criteria is the exploration. When you find when you can decide, you can restart the exploration from the beginning and continue to explore. If you remember that part allowed you to reach a fault, you can decide to avoid that part and to continue to other exploration. It's like you, as an example, I want to go to the back. Okay, if you find a crash here, you can decide to start the navigation, and you cannot repeat this. But if you want to be sure, it's a planning. If you want to be sure that it's not a flaggy test, you can decide to repeat. Because what I observed in my research is that the scheduling strategy and the way you execute the event, I leave you the slides and the link to the paper so you can analyze more in detail this. I found crash by changing the timing between events. If the events are very, very quick, you can have 100 exception. Do you have can you have an idea of why it can be happen?
Maybe because the application is not in the right state
Right.
after perform
Yeah.
on events.
Yeah. Imagine that I click on B1. Okay. I have a change of the state. Okay. Imagine this situation. And I have here button B3. Okay. Imagine that the rendering of the GUI and the execution of some code are performed in two threads. So imagine that in the code I have thread 1 that updates the GUI and thread 2 that works on some arrays. Okay? Array 1 and array 2. Okay? Imagine that when I click on B3, I want to load the first element of array 1 and the last element of array 2. Okay? If thread 2 is very slow, because an example I have to connect to the database for populate the array. When I click on B3 and I want to access to array 1 and array 2, before the two arrays are created or are populated, I may have a null pointer exception. So, another parameter that is very important is the timing between the events. And some of the bugs that I found are strictly related to this parameter. Okay? Okay, I leave you the slides. You have the pointer of the paper, and you, in this paper, you can see the empirical evaluation that we did by changing the parameter. But tomorrow, at the end of the slide, okay, don't read the paper until tomorrow, because I want to show you something. Also, I want to ask you some questions. Okay? Thank you so much. And if there are no questions, I can stop you.
There's a question from Marcel.
Okay. What is the advantage of roboelectric framework over competitors? Okay. I don't know how roboelectric can be better or worse with other competitors. So you have to do a benchmark of roboelectrics with other competitors in order to know which are actually the issues and the pros and the cons of roboelectrics with other competitors.
Yeah.
Yeah. And I don't want to say now if roboelectric is better than other ones or not. So if you want to be fair, you have to build a benchmark and compare the roboelectric with the other competitors. Okay. No questions?
No.
Okay. Thank you so much. Thank you,
Thank
Marcelo and Dan. I don't know if Anna is okay for Anna.
Yes.
Okay.
Yes.
Anna is okay. Okay.
Okay.
Thank you, Marcelo. Thank you, Anna, for your feedback from home or from the office. And thank you. And see you tomorrow. I hope to see you all tomorrow. Okay. We have to